to do that, they have developed a data model and an RDL, a reference data library. And they're quite far with that. It is a mature product. It is ready to be put into the contracts of owner operators, to the EPC contractors. And this is a little bit of a spin-off. In Fleur, we are focused on something new, and that is semantic databases. So we intend to run a semantic database on every project. Fleur is an engineering contractor. We do capital facility construction. And we have at any given time about 300 projects running. And it is always different every project. And that is the thing about semantics. When everything is so different every time, that if you would have a relational database and screens, that would require to be changed all the time because of those versatile environment. That is a problem. We have done that, and we found that it is a problem because we don't have the programmers, the data modelers to do all those changes all the time. And in the semantic database, that is not a problem. You can do any kind of data structure, and the people on the project can do the mapping to the data sources. So that is done by the projects themselves, and that is the big advantage of semantics. Now we found that in our semantic environments, that the CFIHOS is a relational database. We would very much like to have the classes and the properties and the stuff from CFIHOS in a semantic environment. So we proposed that project, and now we have this very interesting CFIHOS semantics project. So let me start with the presentation. So that's the reason for semantics. Why are you doing that? It is easier to do data integration, and they have much more capability. So you can just go ahead and come with your new data structure and connect it up to your existing data. It has rich data relationships, so you can do analytics much better than with relational databases. So, for example, you have all your data in one database, and you can put queries on top of those, and they are called Sparkle queries. And if you want to do that with Power BI, you can do that. We are doing that with Power BI. If you want to make dashboards, if you want to make analytics, all of that is possible. Yeah, a semantic database is very capable of doing that. Don't get me wrong. You can do anything that we do in semantics. You can do in a relational database too. It is just harder to do. So that is something that we have experienced, and we are getting on to grow. So semantics is all about flexibility and scalability. If you don't have need for flexibility and scalability, then you should go with SQL Server, Oracle, that kind of databases. Now, in our environment, we have this thing going on. So data goes from the left to the right. On the left-hand side, you have your engineering data sources, and we have many on our projects. The Hexagon software, the Aviva software, the document management systems, the Siemens software for equipment database, all of that is going on, and there's also much in spreadsheets. That is what engineers like to do, and we are also getting data a lot in spreadsheets from the owner operators, a line list, an instrument list, and you can map that too. So either from a relational database or from Excel files, you import that, and that is called the extract and load. Put it into a first triple store we call data lake, and then from that data we created triples, and we do the translate and the transform. That is a program, and that is the heart of the matter. The translated transform is required for making the triples. So let me give you an example. If this system, and it could easily be, if this system is a digital twin, you would make of a property, a pump has a design pressure. That property will create it with exactly one triple. It's with a pump object and then the design pressure relationship, and you call it, for instance, design pressure in bar gauge, and then you put a number behind it, and there is that. But if you have an engineering environment, that will not do. You will have to have metadata on that relationship. You have much to say about that relationship, about that design pressure. For example, who made it design pressure? Who is the owner of it? Who's responsible for it? And we want to have versatility in the unit of measure. It can be a PSI, and we want to have the data status, and we want to store the data in separate places. We want to have the requirement data together, and we want to have the purchasing data together, so that we can compare it, so that we can find out if the things are delivered that we require. So if you have an engineering environment and you do the same thing with exactly the same diagram that I'm showing here, you would have the design pressure, and that would be like 20 triples. You make an object out of the relationship, you put the metadata related to that object, and so that is the difference between something that you need to just to work like a digital twin, and something that you need a lot of metadata around, and anything in between. And the semantic database can do either or those two situations. Now, what is the yellow stuff? That is, we use commercial software for that, and there are companies in CFIHOS, many actually, that can deliver that kind of software. So that we have a semantic ontology application, and we put the CFIHOS ontology in there. We are doing that project, CFIHOS Semantics, to do that. Now, when you have that, and that is under the control of the engineers of the project, so they can make their own classes, their own properties if they like, and use them immediately. That is not the problem. Then that is being transformed, copied over to the vocabulary in the instance data, and it is used over there in that triple store. Now, at the right-hand top, you see the semantic screen, and that is also something worthwhile to point out. There's only one screen. You don't have to build any new screens if you have a new data structure. The dynamic data will be supported on that screen. And it goes through an API. The API is taking care of all the security. So some engineers on some projects cannot see the data of other projects, and the API takes care of that. So the API is taking the security from Active Directory and takes that and segregate everything so that it remains secure. But obviously, some clients want to have a separate database, and you can do a thing like that too. Actually, it's not what I'm showing here is not really expensive to do. Relational database, I tell you, is more expensive. And then at the bottom, you see there, we are also capable from taking the data from the triple store and output that in a SQL database that is CFIHOS compliant if we want to do a data handover at the end of a project. Now let me show you such a semantic screen. So here is in the same screen I told you about, that single screen. I called up a water feed pump. It appears on those two drawings, and we see that the type is also being expressed in Swedish, because this is a Swedish project and they want to have that in their own language. So the data handover can be done entirely in Swedish. And the construction work package and the work breakdown structure. And you may notice that everything is a link here. And that is the big thing about semantics. I can click on the drawing and then open the document management system with that drawing presented. I can click on the centrifugal pump name and then open the vocabulary or the ontology and get the definition of the thing that is being presented here. I can click on the labels and get a definition of the labels. And when I click on a drawing and get the data from the drawing, I will get everything that is being shown on the drawing. So the relationship back to the tag numbers. I can see that too. So everything is always connected. The only string here is the description of the water feed pump, because there's no further requirement for a link there, but everything else is linked. So linked data is an understatement in semantic databases. You can just click and keep clicking and traverse the data in any way you see fit. So you can see that if you have a thing like this, it is really important that we have a nice RDL to go with it. And if you have to deliver CFIHOS compliant data, you better have your RDL and CFIHOS classes and CFIHOS properties. Otherwise, you have a big mapping problem for your project. So you rig up your project with the seed data like CFIHOS if you have to deliver in CFIHOS format. So that is why we are doing this CFIHOS Semantics project. So what is this CFIHOS Semantics project? First of all, we like to do the visualization of the RDL. So the RDL is, of course, pretty simple to look at. It is a spreadsheet. You can download it from the CFIHOS website. It is all free to download. You don't need to be a member to use it. But we will help you with your project and with your contracts if you are a member. So it will be a way of visualization of the RDL in another way. So that it makes it more approachable. And so later on, when I will do the demo of sous licence, what we are using for our project, you can see that that visualization aspect. But if you use the commercial databases like GraphDB, you have also visualization possibilities to be used. That just comes with the software. Now, the CFIHOS data model is relational only, and I gave you the disadvantages of that. But if you have a relational setup and everything is relational, what you are doing is no use to do semantics. That is just a step too many. But if you're using semantics, then this will be very useful to be added. So if companies are using semantics, this will work for them. And that is what we are doing it for the companies that use semantics. Now, what is the scope of the project? Well, that is a long sentence there. It is the development of semantic models and ontologies and data structures to improve the comprehension and application of the CFIHOS standard within the domain and capital facilities, information management. It can be both project or operational phase. So some owner operators have semantic databases, and they like to get the data in semantics and keep using it like that. Now, what is the objective of our project? We develop semantic models for the CFIHOS standard. We are publishing those models and make the resource available for easy access. So in the end, we will have a semantic setup that you can download and install in your own database, your own semantic database. We try to promote the adoption. That is what I'm doing now, and guidance and support. We get emails all the time. There's a lot of that going on. So what are the deliverables of the project? We want to do the RDL of CFIHOS based on the ODI. IDO, I mean. IDO, ODI, yeah. Both names are being used actually. So you may think, okay, why don't you do it 1596 compliant? I'm doing that too, because I'm also project leader of that. So we do both of that. If you have a 1596 project, you can also use the semantics for that. And we do a mapping from CFIHOS to 1596, and so it's an automatic translation. You don't have to do anything manual. The IDO project is something new. It began in 1596 as part 14, and then they decided to go to their own standard, so that they could also do something else than process plans. Now, we think process plans are enough of a scope, but they want even want to go further than that. They made a structure in the top of the taxonomy that they have, and we are going to use that structure as the top of the CFIHOS Semantics RDL. So if I show you later on the sous licence data structures, the top will be IDO. And it becomes a public system to query the RDL. So you can see the RDL just like you can see the spreadsheets. You can see the taxonomy in an easier way and more graphic. So this is what we do. On the left-hand side, you see the top structure, and this is the entire taxonomy, the entire ontology of IDO. There's not much more than that. And it starts with object, and the object, the specialization of object is information object or a functional object or an organization or an artifact or a location. So on the right hand side, I put the top of the instrument equipment of CFIHOS in the RDL. It has that instrument equipment below it. So that is a complete list of the instrument equipment tops. And below there are all the classes of instrument equipment. And the superclass of instrument equipment is class. So let's not do that mapping, because a class can be also instead of a plant object, also an organization or anything. So we start with the tops that are instrument equipment, mechanical equipment, piping equipment, and things like that. Now, this instrument equipment, how do you map that? Now, the plant objects that are under instrument equipment, the transmitters and the flow meters and the level gauges and stuff, they are inanimate physical objects. So that is where we map it to. An inanimate physical object is something that is not living. That is the definition of an inanimate physical object. So it is physical. So we say in popular speak, we say you can kick it. It is physical, and it is not living. But I also point here at artifacts. An artifact is something that is created. An artifact is we call it man-made, but it can of course also be something else than man, like an AI made. But it is made by something or somebody. And in our world, in our engineering world, obviously, it is manufactured by. That is what we are talking about. So you link it to the inanimate physical object because it is a physical object that is not living, and you link it to artifact because it is manufactured by. So we have this thing going on of two parents that goes to the equipment, instrument equipment class. So is that viable? Is that okay? Because everything else in CFIHOS does not have two parents. In 1596, we have everything has two parents, so we are used to it, but in CFIHOS not. And I don't know yet what is wisdom. If we should just should skip the mapping to artifacts, and because it is not very important that has a link there. It's much more important that it is an inanimate physical object. We might go with that. So that is at the beginning of our project one of the discussion points, and we have many. So what are we going to do for tools? We want to have tools to do that work that I sketched for you. This mapping work, and you can go with commercial software or open source. And as the drawing shows you here, it is very complex to do. When you dive into this stuff, and when you think you know it, there is some academic, knowledgeable person that will tell you that you have it completely wrong, and that you have to model it completely differently. So I have these discussions going on all the time, and the commercial software they have just solved that. You can have commercial software, for instance, that is completely based on SCORS. And SCORS is the knowledge language. In SCORS, you call everything a concept, and a concept can be anything. Can be a class, can be activity, can be anything, or a group. And that is very nice for engineers if they can make a taxonomy and then split up the taxonomy with a group called instrument equipment. Because that group name is not an equipment kind at all. It is a group name. But in SCORS that is all allowed, and many software is based on that. And usually you can commercial software also extend with your own ontology. So you can say, okay, I want to have classes from CFIHOS to be used, properties from CFIHOS to be used in the ontology together with SCORS, and then and make all kinds of relationships that way. And that makes it really very complex. However, we set it up, we make it working, and then we train the engineers, and they don't find it complex. They are trained in it. And this is the way you do it. Okay, this is the way you do it. So all these deliberations about models and academic thinking is not in their turf. That they are just doing the work on the projects, the engineering work, using the tools, and the problems they are for us, for data modelers. So it is very complex, as I said, and that also means that the commercial software for semantic operation is quite expensive. Pay a lot for our licenses, and we see the advantage. So that's okay. We pay a lot, but we do our projects, our engineering project. But of course, in CFIHOS we have many other types of companies that also want to do this. And they don't have capability of expensive licenses. So there's also the open source road, and that is what we chose for. So we have made the product sous licence. There's a couple of sponsors from CFIHOS in there, mainly Total Energies. And we are very grateful for that. And there is a company or an association called Knowledge Graph Association, the KGA, and they are hosting it for us, also free. So I'm very glad with that situation, and we are now going for our project to the open source route. Now, where can you find this open source sous licence? So this is how you write it, sous licence. And it is the open source part of it is on GitHub, and this is the address: GitHub sous licence vocables. And we have a host on the Knowledge Graph Alliance, and this is the address for the Knowledge Graph Alliance. And yeah, so this concludes my presentation. I'm now intending to give you a demonstration of sous licence and what we are going to do in CFIHOS Semantics. But before I continue, do you have any burning questions?
I have one. I would like to know where can I actually download the CFIHOS ontology, if there is one. I mean, independently from the sorry, I don't know how to pronounce that. Lens. Independently from the tool. Yeah, well, lessons. Independently from the tool, I would just be interested in the actual ontology. Is that something you can download independently from the tool?
Sure, I will show you. Let me see. Google. IOGP. So CFIHOS is an acronym that stands for Capital Facility Information Handover Specification. And we say CFIHOS because CFIHOS does not sound very well, so we say CFIHOS. IOGP stands for International Oil and Gas Producers, and that's about 100 companies in the oil and gas environment. And they have adopted CFIHOS and taken it into their control. And we are very glad that they did that. And so this is what you should query. And it is over here. It is not the first one. It is the second one. CFIHOS Home, JIP36. JIP36 stands for Joint Industry Project. That is what they call the projects in CFIHOS. Sorry, in IOGP. So we are 36. There's also an important project going on in IOGP, that is JIP33, and that is about equipment datasheets. That we are doing that too. We are standardizing equipment datasheets, and we are getting a lot of properties from that we are porting into CFIHOS. So if you go to the standards over here, you can scroll, and here you can download everything. Okay, so let me give you a little bit of an overview. The reference data library, here is the Excel version. That is the one you should download. don't bother with the CSV version because you just get a lot of CSV files, and it is no use for us to look at. It is for computers. So the Excel version has RDL in it, and it has a lot of tabs with different types of data. So there is a tab called tag classes, and there's a tab called equipment classes. That is where you should start. And from there on, you go to the tag class properties and equipment class properties. And so you pen out and just find the classes, the properties, the lookup values, the lookup lists. All of that we've standardized. Now the data model is over here, and we have the data model viewer, and we have a data dictionary, and we have a PowerPoint that you can look at to see the data model itself. So that will show you all the relationships that there are between plant equipment and their documents and their process data, and etc. So it's a very big data model that you can use very lightly or very heavily. So when I say you can use it lightly and heavily, that is about the supporting templates. So in here you have the CFIHOS scenario templates, and that is showing what you should use if you want to have a very simple handover, like for instance only documents. So documents only, you will have maybe tag numbers and also all the documents, but that is where you stop. And then every situation in between until the situation where you use everything of CFIHOS, so the process data, the vendor data, all that stuff that is in there. Now over here is the narrative documents. They are also really important. So the specification document is something that you put into your contract if you want to give out a contract to an engineering contractor. And the scope and procedures show you what is being used. And the implementation guides are very good to read. So there's one for the principal and one for the contractor. And that explains everything, how you should use CFIHOS and how you should use a CFIHOS contract. And how you should build up your CFIHOS project, your handover project, and things like that. So all of that can be downloaded here. And of course, we expect your email with your questions. We'll answer your questions as well. Is that good? Is that the answer to the question?
Yeah, thank you. Yeah, thank you.
Yep. Okay. Any other questions?
This is Niels. There have been a discussion going on the chat, and I don't know if the questions that has been raised have been answered. So I'm just asking. I think it was Per-Øyvind Øverli who started this chat on discussion. So I'm asking really, has the questions been answered?
Does anybody have a question that is about the chat questions? That is the question that Niels has.
I did my best, Onno Jean-Charles speaking, to answer progressively during the presentation. So I think you can go on and we can have a Q&A at the end of your presentation and demo.
Okay, good.
Okay.
I will continue. I'm logging into Solutions now. I gave you the address. It is on the knowledgegraphAlliance.org. I logged in. Apparently, I already have a cookie, so I've logged in with my name over here, as you can see. So it is a login password. And we can give access to the people that are working on CFIHOS Semantics. We begin over here with the menu. So the graphs that we create are over here, and I got a couple of them, also test graphs and things like that. We have the IDO 3, so there's a new version coming up, and that will be used then. We have put a ready project in here. That is a Norwegian project that is already finished and came up with a semantic taxonomy. And we have done some tests for CFIHOS over here. The BFO is put in there. It's also a standard. And we intend to start with the CFIHOS semantics that does not exist yet over here. Okay, then there's a Sparkle endpoint if you do want to do queries on top of the semantic taxonomies. So if you want to make reports out of it, Sparkle is just like SQL. It comes out with tabular format data that you can use. And you can also use Sparkle in Power BI and other report tools. I start here with Weaver. It will give me a source selector. And we have, the reason is not important, of course, but we have here the OWL ontologies. I'm going to open the IDO 3. You have to be careful that you click here on the triangles and not on the items, because that will not work. Just so that you know. And I can open IDO 3 over here. And this is the top of IDO, of the standards. So they have a taxonomy, and this is about it, but what you can show. I can zoom in a little bit. So here is your physical object and your inanimate physical object. That's what I showed you. You can click on class here, or you can search on something and then click on class, and then that will give you a subset. But this will give you also a tree of the same thing that you see over here in the graphical interface. Sometimes the tree is just more information. So over here you have this inanimate physical object. If I click on it, right click on it, and then click node info, I can see what the triples are that are behind this single class. So you can see subject predicate object there, those are triples. So the UUID over here, you can see here. This is typically linked data. So you always have a namespace and a fraction identifier. So the namespace is until the last slash. And the namespace is the address of the owner. So in this case, the ownership is postcaesar.org. So if we do link data on our engineering projects, the ontology and the vocabulary are usually like this. So the namespace will be the name of the project in that case, and the fraction identifier will be a name in camel case, like here, inanimate physical object. And the fraction identifiers of the plant items, so the actual valves and the pumps and the lines and vessels. We use UUIDs for that, so you can see the long-winded numbers for that, and that is to keep it unique, so that if you import stuff to a relational database, you can use that as a primary key, and it will still be unique. That is the big advantage of UUIDs. Now, when we hand over the data, the namespace will differ, because I just said to you the namespace is the ownership. So when we hand over the data, then this part will be the name of the owner that we hand it over to, and And if they put up a database with an endpoint on the internet or on the intranet or on or via a VPN tunnel, you can look at the data over there and see all the data of their operation and maintenance of all their plants. Now, so this is the subject, and then the predicate is over here. You have label. You see also example is primitive. So the predicate is always the name of the label, huh? But it's also linked data. So the predicates also have a namespace and a function identifier in camel case. And the namespace for predicates are, of course, the name of the ontology or the standard. So most of these will be IDO names. What subclass of, for example, is the RDF standard, which is a standard made by the W3C. So you will see the RDF standard over there as a namespace. And on the right-hand side, so on the right-hand side of the triples, you will see everything that it is pointing at. So the label is inanimate physical object for this class. You can see it also in this standard. Here's an example for an inanimate physical object: a tool, a building, a vehicle, an instrument, a parking lot. Is it a primitive? Yes. So it's a third class class. What is the definition of this class? A physical object that is not living. I told you about that definition of an inanimate physical object. It is something that you can kick, but it is not living. And then the primitive rationale. So somebody explains why this definition has been used. An account of what is living means it is beyond the scope of IDO. So they say, okay, we have discussed if we should give you a better definition, but we think it is beyond our scope. It is a subclass of physical objects. Now we saw that we have here physical object there. So it is a subclass of physical objects. And the type is an OWL class. So this is the namespace for the standard for OWL and the camel case class. So that is the type of this class. If I go to this other one, the artifact, I already showed you that the artifact is a physical object that has been created as a result of a deliberate activity. And we used to say man-made, but of course, since AI, it is not only man that makes stuff, so it is now a activity that makes it. So that is how they define it. So I want to show you a little bit of how we are going about this mapping and creating of the ontology. Now, over here is the Onto creator. Only few of us, the ones that are in the squad for semantic RDL, get to run the Onto creator. And our team is small at the moment. So Onto creator can create a new ontology and the classes and so on. And that is what I'm going to try to do now, so that you can see how we go about it and how you can use this tool. So I want to make a new ontology. I think test 4 is the number at the moment. And we say our own names because all the ontologies are together. I showed you that. So I now give the name so that we know who to blame for it. Now I'm just giving a namespace just for demonstration purposes, and it is normal to give the example.com namespace for that kind of purpose. It is a namespace that is allowed to be used by anybody, and that is that IP has been established. So it's always good to use example.com or example.org or whatever. So we can say this ontology, do you want to do it completely on your own, or do you want to base it on something? And we want to base it on IDO. So we are going to the IDO 3 at the moment. So that is in the question and answer game, we say IDO 3, and now I create a source. But what do you want to do now? Do you want to upload the graph from a file or from URL, or do you want to finish? Well, I want to finish. And now it creates my ontology. It is empty, obviously. If I click this, it will give me the top. If I click it, nothing happens. Over here, I get add resource or add relation. I have to click add resource. So I'm going to create a class. And the resource label is pump. And I want a reference ontology. I want to say IDO, and I want to say inanimate physical object. And you can draw it now. And so now I get pump over here. So finally I get something. I want to make a centrifugal pump as a subclass of this. So for demonstration purposes, so I'm going to add another resource, also a class. Okay, there's my centrifugal pump. Now, I want to say that centrifugal pump is a subclass of pump, and that is where I end my demonstration, because that is already enough to go for. So I add a relationship, and this is very tricky. You have to know what you're doing here. You have to click at the relationship, then click this and not let go. Just drag and drop, and then let go over here, and that is how you make it. If you don't know this, you're completely lost. Then I want to make this relationship. So it says, but what can you choose from the ontology that you have? So this is coming from RDF, and this is coming from IDO. And obviously we will have other relationships too that are coming from CFIHOS, so that will be also added. But I'm now going to take an RDFS subclass of relationship. Okay, now I can right click this centrifugal pump and say node info. See what triples I now created. So it has namespace example test 4, extraction identifier centrifugal pump, and I see my error here. I should have done it the camel case and not use a space over there. And the subclass of pump. So and the pump is an inanimate physical object. It is a class, and the label is centrifugal pump. All of that, of course, is editable. So if I started with the camel case name, it would have created it like that. And then I could have changed the label to something that has a space in it. Now, what is then the idea of this stuff? So I have created this. What do we do now? We are going to create a turtle file from this. And the turtle file can then be viewed and see how it is done. Then we make a program that creates the same structure as that turtle file, but then from all of RDL of CFIHOS, and create that huge turtle file from the CFIHOS data, and then upload it back, and then we have an ontology. So we don't intend to do this manually. We intend to do it like that with the program. Now, how do you do that? You go over here, you download this. Can be n-triples or can be turtle. Let's do turtle. I will explain the turtle file to you. Okay, it is created over here. I can open it in my editor. Let's use VS Code. And here's the turtle file. Now, how does turtle work? First of all, I have to tell you, we like turtle very, very much. It gives you a nice overview because of this. The prefixes. So the namespaces of the data can be made short as a prefix. So after this long namespace can be called DC terms, and this can be called NS1. So you put those prefixes over there, and now it becomes pretty much readable. And so we use Turtle all the time for this. So you can see the triples like this. So this is the subject, predicate object. So the letter A is the same as RDF type. So centrifugal pump is a class. And then you see the semicolon, and that means the rest of the lines now become to have the same subject. So the triple is always centrifugal pump label this. Centrifugal pump created this. Centrifugal pump creator Onno Paap. That is how it works. But it is nice underneath with an indent, so we can read it much more easily this way. Now, this is what we get. We get the label triple, we get the created, creator, and source. The subclass of, the centrifugal pump is subclass of pump and of inanimate physical object. So there's a comma here, that means there's a second triple that is almost the same as the first triple, but in the end it is another address. Now, and here is pump. Now, as you can see, it's pretty simple if you know how to look at it. So we can just create a nice program in VBA or Python or something. Take the spreadsheet from the RDL of CFIHOS and create this turtle, but then a big one, and then load it back into Sous Sans, and then we have a complete CFIHOS taxonomy there. That's about it. This is what I want to show you. We have 5 minutes left. So do you have any questions?
Hi, I have a question. So you have shown us the CFIHOS data dictionary downloads, and you have shown us an ontology editor, but CFIHOS is pretty big, maybe 500 classes, maybe 2,000 properties. Do you plan to recreate CFIHOS by hand in this ontology editor, or do you plan to generate the ontology using some principles from the data dictionary, using some restructuring along the way?
Yeah, so we are
No, I can answer to this question if you want. Claude Fauconnet, the author of Sous Sans. So we didn't show it there, but we have tools in Sous Sans suite where we can import CSV tabular data and transform them with mappings into triples. So it is something that we will propose for a next workshop in CFIHOS. To show how you can transform the CSV data of CFIHOS into triples, and we will make it. So, of course, we will not do by hand thousands of triples.
More questions? I think it's about time, Niels.
Almost. Niels, you are muted.
You have to unmute, Niels.
You are muted. I think he's finding the button.
Still muted, Niels.
You are in mute, Niels.
Oh, sorry.
Okay.
My usual problem. I said last time I spoke that there are been a discussion on in the chat, and when I and a couple of other people will look at that and we are planning to have a question and answer and discussion session of related to the 3 presentations of CFIHOS we have had. So that will be next Friday. So we will see if what we can have our answers at that time. And there's one thing, if any of you have questions, could you please send it to us, to me or to Onno, and then we can answer them next week. And I think that is all I have to say. Any burning things we need to discuss, to mention before we leave? If not, thank you so much for attending this
session.
Thank you.
Thank you.
Thank you.
Goodbye.
Thank you.
Bye. Thank you.
Bye.
Thank you. Bye.